Thank you, Pam. Thanks for moderating. And thanks everybody for joining us. As Pam said, it's our first virtual demonstration event of a toxics use reduction project. The plan was to do this in person, but of course plans changed. And we greatly appreciate Riverdale Mills for being willing and able to do something different with us like this. And though we don't get the in-person benefit of seeing the equipment live, we feel that this is a great opportunity for people all over the state and the country to be able to join us more easily since we're doing this virtually. So for those of you who are not with us in Massachusetts and maybe not particularly familiar with the Toxics Use Reduction Institute, I'm just going to give you a very brief overview and then turn it over to the folks at Riverdale Mills. So the Massachusetts Toxics Use Reduction Institute is part of the Toxics Use Reduction Act. We've been around for quite a while now. Our goal is to reduce hazardous byproduct generation and simply the use of toxic chemicals within Massachusetts. And the objective is to help companies and communities to reduce those toxics and also help them to promote their competitive advantage throughout that process. Under the Toxics Use Reduction Act, the companies must report their annual amount of toxic chemicals used. They must complete a planning process every 2 years, and they must pay an annual fee to the state program. And the core principles of the Toxics Use Reduction program is really source reduction, getting rid of the toxic chemicals at the start, eliminating it from the process, and that way eliminating other downstream issues. If that is not possible, then there's other ways to make improvements to limit and reduce the use of toxic chemicals. The 6 toxics use reduction techniques that are taught in our toxics use reduction planning course are input substitution, product reformulation, production unit redesign or modification, production unit modernization, improved O&M, or recycling if it's integral to the process. So you're going to see one of these TUR techniques demonstrated in our demonstration event today. And there are 3 different agencies that work to complete the toxics use reduction program. Massachusetts DEP has staff that work on the compliance end of things. Massachusetts OTA, or Office of Technical Assistance, does free, confidential, on-site technical assistance visits to companies within Massachusetts. And then us at the Toxics Use Reduction Institute, where we focus more on training, grants, research, alternatives assessments, policy analysis, technical support, and we also have a cleaning laboratory as well as a library full of resources for you. The industry grant program is one of the programs at TURI, and this is how we connected with Riverdale Mills most recently. They applied for an industry grant and were awarded one. The grant for next year, just the applications were just due on Monday, so that process will begin again for our next fiscal year. But folks in Massachusetts are eligible if they have a manufacturing facility that's the location of the grant project and they're part of the TURA regulated universe. So just to give you an idea of other projects that have been ongoing at TURI during this year, we had a facility replacing an NPB vapor degreaser, a facility replacing TCE with a safer alternative and a dryer, and Riverdale Mills, our facility today, reducing several different materials by reducing drag out. MSI Transducers is a facility that reduced using lead in their manufacturing process. Metal finishing company reducing the use of acid, and they're going to be our next demonstration event. We haven't yet scheduled it, but stay tuned and we'll let you know when that's planned for. And then also a soup manufacturer in Lowell, Massachusetts that's been testing alternatives to sodium hydroxide for cleaning. Just to give you a flavor of different types of projects we have going on under our grant program. If you have other questions, please feel free to visit our website and email me with any questions or give a call. And with that, I'm going to introduce you to Shuai, who's the process engineer at Riverdale Mills. He has 5 years of experience in mechanical design, and he has proficient experience in continuous improvement, new product introduction, and process validation, as well as various metallurgical processes. He's always looking for creative and cost-effective solutions to solve challenging problems, and that's why it's been such a pleasure to work with him this year, because that's exactly what this project is all about. And in his spare time, he is a professional landscape photographer, so you'll get a glimpse of his talents here as well. So with that, Shuai, it's on to you.
Thanks to Joy for giving us this chance to introduce our project, the geographic cycling system. So my name is Shuai. I'm the process engineer of the Riverdale Mills Corporation. So today I would like to show you how this project and how we develop this project and how we can collaborate this project with TURI and how this project working, and eventually how this project benefit for our company. So can everybody see my screen?
Yes.
Okay. So Riverdale Mills Corporation is one of the largest wire mesh and wire manufacturers located in Northbridge in Massachusetts. So we produced all the wire mesh, PVC coated wire mesh, galvanized wire mesh, and we have over than 200 employees in our headquarters. So our products, such as we're making the drawn wire coil, and we're making the welded wire mesh, and also we do a galvanized process. So we produce the galvanized wire mesh and hex mesh, and also the PVC coated wire mesh and hex mesh. So you can see on the top two pictures, we have PVC coated wire mesh in various colors, and on the bottom three pictures, there are galvanized wire mesh and hex mesh. So our customers are everywhere. So we produce our products in agriculture industry and
Shuai, I think we've got some connection issues. There we go.
Yeah, for the landscaping support. So especially one of our two major products are the lobster trap and the crab pod. So since we own over than 90% of market share in this business, so 9 out of 10 lobster you eat probably is captured by our products. So how we make our lobster traps, how we make all this wire mesh. So I presented the processing here. So from the beginning to the end. So firstly, we purchase raw coils and we draw all this wire into the specific gauge. So the gauge stands for the specific diameter of the wire. So after that, we have the drawn wire coil. Then we welded all those wire coil together. So all this wire becomes wire mesh rolls. So we welded on our giant welding machine. After that, we do the galvanizing process, which is our TURI projects located. So the galvanizing, for audience who are not really familiar with galvanizing provides the thin zinc layer on the surface of the wire mesh to protect the wire mesh from the corroded condition, just like sea waters. So we call this product as GEW, galvanized after the welded products. And next, all those GEW products, those wire mesh roll, will be PVC coated on our PVC coating line. So the PVC coated will provide extra protection from the physical damage and corrosion situation. And ultimately, we share and trim all this wire mesh into the specific size, just according to our customer requirement. Then we ship it out of finished product to our customer. So in this video, I'm gonna shortly present a part of the welding process as an example to show you what our products looks like. So as you can see, all this wire, we have 4 strips of the wire mesh roll and welded simultaneously on our giant welding machine. And all this welded wire mesh roll will be coiled on our machine spindle. So the machine spindle will coil all the products together. Once the number on the counter reaches the target length, the machine will automatically stop and inform the operator to cut all this wire mesh roll in a specific length, and all this wire mesh roll will be shipped to the next process, which is a galvanizing process. We're waiting for it to be galvanized. So ultimately, all those wire mesh roll will be welded, galvanized, PVC coated, and trimmed into the specific size and ship it to our customer. So there are three types of major chemicals we're dealing with and we want to get rid of. So the first one is hydrochloric acid. We purchased 24 ml hydrochloric acid and dilute them in our acid cleaning process, which is a part of process for our galvanizing line. So the acid cleaning process will remove the oxide layers and rust from the surface of the wire mesh so this is a part of the surface pretreatment process. And also we use ammonium hydroxide to correct the pH in rinse tank, which is the process after the acid cleaning process. So why we want to correct the pH is because if the pH is too low, it will affect another process, which is called the fluxing process. And we don't want to see that. So we have to use some ammonium hydroxide to correct the pH in the water rinsing tank. And another one we're using is sodium hydroxide. We use the sodium hydroxide in our wastewater treatment system because the acidic water in the acid rinse tank will be drained into our wastewater treatment system. So we need to neutralize all those acidic water to meet our regulatory requirements from DP and DEP. So there are three types of chemical we need to address, and we want to reduce usage of all of them. And I will present how we do that in this project. So why we want to make any change in this project? So firstly, I want to show is the cost, because the cost means that we spend more money on those extra chemical we don't have to use. So reduced cost is one of our really big motivation. And the second is the quality. We want to improve the quality by continually improve our process. So we need to improve galvanized yield rate by changing the process or changing any parameter on this galvanized line. Thirdly, we want to perform the TURA, Toxic Usage Reduction Act. So by doing so, we need to reduce the specific chemical use. And at last, as a process engineer, I feel like I have a responsibility to protect our employee, especially for like production operators, production supervisors, since they are the personnel to create the value for this company. So as I first designed this project, one of my team members mentioned that you should contact with TURI because they have the resources. They have really wide network, which I can find a similar project. And they also, they provide funding for this type of project. So I directly make an appointment with Joy from the TURI, and I drove about 40 miles headed from Northbridge to the headquarters of the UMass Lowell to meet with their professional staff. And surprisingly, they provide us a lot of professional recommendations. How do we troubleshooting it? What is the root cause of all this information? And also, they provide funding for our project. So I list the 3 bullets in of this project. So they provide guidance on the project approval, and also they provide the funding. At last, they supervise the timing of the project milestone to help us to achieve this project. I have to say, without the TURI, we probably cannot finish this project on time and finish this project successfully. So in here, I show the surface pretreatment process on our galvanized line. So we can see where there are several tanks and several lines in this project, in this diagram. The black line with the arrow indicates the moving of the wire mesh. So firstly, the wire mesh will be rinsing in the first rinsing tank, and then the wire mesh will continue to go through the acid cleaning tank to perform the acid cleaning process, and then the wire mesh will continue to go through the second rinsing tank to wash out the acid residue on the wire mesh surface. And at the last, the wire mesh will continue to go through the fluxing tank and directly head into the zinc kettle to finish the galvanizing process. As considering this process as a continual process, so the wire mesh will continually carry out the liquids from the previous process to the downstream process. So in this part, I use the blue dashed line to indicate how the drag out liquids moving. So firstly, when the wire mesh travels through from the first rinsing tank to the acid clean tank, the wire mesh will carry out some liquid on the surface of the wire mesh to the acid clean tank. So this will cause a dilution issue because those water goes in the tank will reduce the concentration, and we want to maintain the specific concentration in the acid clean tank. So that's the one problem. And also, once the wire travels through from the acid clean tank to the second rinsing tank, the wire mesh will drag out all this acid to the second rinsing tank, will cause another issue because it will cause a contaminant issue in the rinsing water, cause the acidic water, and also will reduce the amount of the acid in acid clean tank. And those are things we don't really want to. We don't want to see. I use the red dash line to indicate where we adding the chemicals. So firstly, we adding hydrochloric acid and we dilute it into the acid cleaning tank in specific concentration and specific water level. And also we adding the ammonium hydroxide at the last baffle of the second rinsing tank to maintain the specific pH in the last tank. So in the last pH, because we want to prepare the wire surface into the fluxing tank, because that's a really important process in the galvanizing line. And once all those acidic water drained into the wastewater treatment, we need to add in a sodium hydroxide to neutralize the wastewater treatment. So these are the pre-treatment process for our galvanized line. So pretty obviously, there are three types of the chemical and really high use, and those are root cause analysis for this project. Why we need to use a hydrochloric acid, why we need to use sodium hydroxide. So hydrochloric acid is caused by the drag out water and drag out acid, and the high use of sodium ammonium hydroxide because the drag out acid causes into the uncontrollable pH in the rinsing tank, and also high usage of sodium hydroxide is because the drag out acid are contaminated our rinsed water, and those rinsed water drains into the other wastewater system, and we have to use more sodium hydroxide to neutralize all this rinsed water to meet our regulatory requirements. So what's root cause? So the root cause is how can we eliminate or reduce the drag out liquids. So those are the core, the root cause we want to deal with. So there are several potential solutions, but the major concept is the same. We need to isolate the hazard where it belongs. We need to put the rinsed water back to rinse tank. So we need to stop the moving of the liquids from tank to tank and put them back to where their original tanks. So this is the main concept for this whole project. So me and my team did a brainstorm, and we want to figure out a couple solutions for this project. How can we stop moving out of liquid? So one of my team members said we can purchase a really expensive evaporators to evaporate all the acidic water instead of let them go to the drain into the wastewater treatment. I said it's not a really good solution because firstly, the equipment is really expensive. It's like $100,000 or $1 million. It's not worth to do that. And also, the utility cost is really high. Thirdly, which is really important, it does not reduce the usage of the hazardized chemical. And another my team member mentioned that can we use a heat air blower or an air knife, which is commonly used in industries. So we use such technology to sweep the liquids from the wire mesh and stop it traveling from one process to the other process. Well, I said it might work, but as I said, the air knife utility costs on air knife is really, really high because we're running the plant 24/7, and also it does not reduce the usage of the chemical, and it's not reduce the cost, and also it has a potential risk because you don't want the air blower all this hazard into the air, so that's not safe for our production employees. And also we think about other chemical to neutralize acid water, but the point is same. It doesn't reduce the usage of the chemicals. So what we want is that we want to solve the problem, not creating another new problem. And also we want to optimize the process, but not fix just a symptom. So I contact with TURI. We're looking for several potential solutions, and there's one idea, and they mentioned and really inspired. So I think you guys really familiar with the car wash. So when we do a car wash, we have two spindles on the side with the brushes, so it can remove most of the liquids from the surface of the car. So I think I come up with this idea when I do the car wash. I think, can we use this concept on our production line? So I will show you what this looks like after we implement on our production line. So think about all the wire mesh as the car. So we have two cylinders on top and the bottom, and we let them rolling, and we eliminate the acid, sweep them off from the top, and sweep them from bottom. And I present this idea to our team members, and our team members, why not? Let's give it a try. So we developed several benefits for this project by using this dual brushes concept. So firstly, it has really high surface liquid removal efficiency, because long time ago we're trying to use similar technology to remove the water, but somehow we never use them to collect the acid. We never use them to remove the acid from the surface. And secondly, because it's a really acidic condition, we want to use something which is heavy duty instead of use another fancy, expensive equipment which won't last long over than a year. And thirdly, we don't want any chemicals in our process, but instead we want to physically remove all this acid from the wire mesh surface. And as you can see, the cost is controllable, and we also can in-house fabricate other parts. And what we mostly need is the pump, the shaft, and the take-on frames. And as we can see, the utility consumption is really low compared to the air knife and the other technology. And in the future, we still can expand this whole project into our SCADA and other PLC system. So this is what we looks like after we finish this project. So I installed one tank, the first dual brush tank between the rinsing tank and the acid clean tank. So this tank will sweep the water from the surface of the wire mesh and collect them in the dual brush tank and pump it back to the rinsing tank or drain into our wastewater treatment. And also, the second dual brush tank is located between the acid cleaning tank and a second rinsing tank. So this tank, the brushes will sweep the acid from the surface of the wire mesh. So the acid will be collected in our tank and will be pumped back to the acid clean. So I created two independent closed loop to stop the moving of the acid and other liquid from moving from one process to another process. So that's how I implement this concept, stop the moving of the liquid and keep there where it belongs. So I present this idea to the TURI, and they really interested in the whole project. So I'm really excited about the grant, because when I remember that the day that the Joy mentioned that your project is won the grant, I was like, yes, because our team want to get this project done as fast as we can, and we know the benefit is huge, and we want to see how much acid we can recycle, how much acid we can hazard chemical we can save from this project. So we started this project at the last year on October, and we just only spent about 5 to 6 months to finish the whole project. So at least a timeline in here to demonstrate how we start from the beginning to the end. Firstly, we do the engineering designing. So we need to design tank size, we need to design the frame size, and so I developed the CAD modeling in the SolidWorks. So there are several parameters need to be considered. Firstly, how high will the shaft be? What the material we're using in this tank? What the size of the frame? Do we want some automation? And what do we do? How we deal with the chemical inside of the tank? Excuse me. Do we want to recycle them? Do we want to drain them to the wastewater treatment? So we developed several options in the engineering design phase. On a stage 2, we developed the PFMEA, process failure mode and effect analysis, and the DFMEA. So, and also we developed bill of the material. So those are documentation can be archived for this project, because we're not only using this project in Gapline, we can also duplicate a similar application on our other production line. So those engineering documentation are really important for our plans. So once we approve all the design, we will start to contact with our vendors and fabricate the brushes and the shaft and the take-up frames. So I contact with several brushes vendor, and they told me that they have never heard such application, but they're willing to customize a similar brushes for us just to see if it's working. So I ordered about 8 bristle brushes from a vendor called Brown Brushes, and I contacted with the water jetting companies to cut the plate for the support of the take-up frames, and also we fabricate the in-house frame. So to the frame while holding the tank, and the shaft while holding the other brushes. So we spent about like 6 to 8 weeks to fabricate all the parts together, and the tank is ready to go. In the stage 4, we scheduled 1 or 2 days downtime to install all the tanks on the production line. So I talked with all my mechanics, electricians. So we work together to decide this is where we install it, and this is how we install the tank, because we want to make sure everything we install is properly, the height is correct, and the brushes is functioning correctly. We spend about 2 days for the installation and the commissioning. Once the tank is all set, we spend 50 days on the performance assessment, because we want to know if the tanks do their job. Does the tank collect the acid? Do we save any chemicals from this project? Those are the questions we want to know the answers. So I was there for 50 days, manually collect the liquids from the tank and write on my Excel sheet just to see how much liquid we collect in the tank and how we evaluate the whole project. So we did the PFE. I put an example of the PFE main analysis in for our project. So you can see I put the gearbox failure. How if the gearbox failed, what are we gonna do? If the ultrasonic sensor failed, what do we do? So those are preventive maintenance for our maintenance department and how we correct the process. So these are the potential failure for our new dual brush tanks. So then these are the drawing I developed for for my dual brushes tank. In the left corner, it are the frames to hold up the tank. In the right corner, there are shaft and the brushes. So the brush is really hard to fabricate it because it's a solid stainless shaft. It's about 100 inches long, and it takes me for a while to find qualified shops to fabricate out the shaft. And in the left corner is the BUM and what is the assemble drawing for the whole tanks. So this is the CAD modeling in SolidWorks. What is our tanks looks like? So the material I picked is different. So at the frame, I picked the general E36 metals, and for the tanks we use fiberglass tank, and at the bottom we have a drain connected to the pump for the recycling. On the both end of the tank, there are support plate, and for take-up frame installed with the bearings. And inside of the tank, there's several baffles, and also the brushes will be bolted on the solid stainless shafts. So these are the pictures, shows how we install the tanks. So in the left pictures, we welding the brushes together, and these are pictures, and on the left corner is how we fabricating some support plates for the tank. And the picture in the middle is the day we assembling all the tanks together, and we're doing the commissioning. In the right corner, there's a picture while my employee trying to paint the frame to give the whole tank extra protection. So these are our hard work employees, how they help me in this project. And as I said, the teamwork in this project is really important because we want to make this new implementation done. We need to get this project done correctly and get it fastly. So we also installed, we use the old ultrasonic sensor, and also I put a controller panel on the side of the galvanized line. So the control panel provides the level data for the daily checking. So it will measure the acid level, the distance between acid level to the ultrasonic sensor. So I can know what is level in the acid cleaned. It's in the dual brushes tank. So the ultrasonic sensor will automatically measure the acid every day, and the control panel will control the pump to pump the acid, automatically pump the acid back to the acid clean tank. So it's a closed loop automation process. So our employee don't have to manually pump the acid back every day. So those are tanks. What does the tanks looks like? after we finish the installations. So in the left one are the projects, are the first dual brushless tank, and on the left, on the right side is the second dual brush tank. And if you notice that I changed the brushes color on the second dual brush tank, so to make it more obvious, so we can identify which on the top, which on the bottom. So in the next slide, I would like to provide a video to show how this tank is functioning. So this is a video for the first dual brushless tank. So as you can see, there's plenty of the water residue, rinsed water attached on the wire mesh, and it will travel out of the first rinsing tank, and it will be continually bring into our acid cleaning tank. And those water, it will cause our dilution issue. So the two brushes in rotation, one is rotation clockwise and the other will rotate anti-clockwise. So the brushes will continuously sweep out the liquid from the surface of the wire mesh. So as you can see, all the liquid will be swept out from the surface and collected instead of the dual brushless tank. So this is how the dual brushless tank functioning, because we want the liquid removed from the surface of the wire mesh. And obviously, plenty of the liquids are successfully be swept out from the surface and they're collected in the first dual brush tank. In the next one, this is the second dual brush tank, and the hose is connected with the acid cleaning tank. So the second dual brush tank is a similar specification, similar design to the first dual brush tank, but the second dual brush tank will remove the acid, which is low concentration acid, from the surface of the wire mesh. And it's the same idea. All this acid will be removed and collected inside of dual brush tank. And on the right side is the second rinsing tank. So the dual brushes will prevent the acid traveling through from the acid cleaning tank to the rinsing tank. So at the bottom, I implement the PVC pipe and strainer and the magnetic drive pump. So it will controlled by the ultrasonic sensor, and the acid will continually pump back to the acid cleaning tank. So this shows you how the acid removed and how the acids function on the top. And the control panel indicates there's 13 inches between the ultrasonic sensor and the acid level. So we did a 50 days performance assessment after we installed the two dual brush tank. I collected the data only in the second dual brush tank because it accumulated a low concentration of the acid, which is way more important, and this is the problem we want to deal with. On the left too, I plot the gallons of the low concentration liquids on this diagram, and on the histogram it provides what is the average liquid and what is the standard deviation we have during the 50 days. So during the 50 days, we saved about 47.4 gallons of acid. So these are gallons, is 24 million gallons acid compared to we used last year. And we saved about 20.13 gallons of this ammonium hydroxide, and we saved 107.4 gallons of sodium hydroxide in our wastewater treatment. So those numbers is really big, and our team are really excited about the end, about the result we have. However, there are still some factors affect how many liquids we collected from the wire mesh surface. So firstly, we have the wire gauges, different wire gauges, different mesh size, different running speed, different height of the brushes, and the running width will always change the collected liquids volume which in our dual brush tank. So if you see there's a really low number on the right side, only about like 36 gallons on that day, it's probably because we're running a thin layer instead of a heavy gauge layer compared to the 80 gallons collected in a day. So those are the factors will affect how much gallons we collect in a day. So in this one, our team did a cost and investment analysis. So we combined all three periodic chemicals cost we have before and after, and it turns out we save about $683 a month by operating this project. But however, this project also gives us some change because we need adding the labor maintenance. We need our maintenance staff to calibrate our ultrasonic sensor, to maintenance the pump, and also we need to maintenance we need to grease the oil in the bearings, and also it changed a bit in our waste disposal. And also we have $180 utility cost a month just by running the pumps and the drives. So we also increased the cost of the safety glasses and also gloves and other PPEs. But if you look at the monthly cost and saving chart, we still save $450 a month just by reducing all those hazardous chemicals. So in the second chart, we did a capital investment calculation. So as you can see, we spent about $4,000 on to fabricating the stainless steel solid shaft, and spent about like $1,000 on water jetting service to cut out the spark plate, and also we spent about $2,000 on the brushes and $655 on the pump. And totally, we spent almost $12,000 on those entire project. So we did ROI calculate by using the formula we present on the bottom line. So it's the 45.669% we have. If this number is not satisfied enough, I would like to show you what is projection in the 5 years. So after 5 years, we'll see with the total ROI will reach about 312%, which is really, really good for our company benefit. And as you can see, at the second year, we will have over 100% ROI, which just means all the money we invest this year on the entire project will be paid by receiving all those hazardous chemicals. Not even mention that we have the grant from the TURI. So at the end of the 5 years, our company will benefit over than $20,000 in saving the chemicals, in saving purchase the hazardous chemicals. And also our company are able to reinvest all this money in other TUR projects to improve our process. And ultimately, we want to expand all this process into our automation system like a SCADA. So those are our expectations we want in the next few years. So what do we learn from this project is that firstly, we need to work as a team. We have a great team members. We work together. We have mechanics provide the answer where we get started, where we want to put the tanks, I have an electrician give me the advice about how we automatic to measure the acid level into a brushless tank. And we want to be creative about the solution. So we want to use the most creative method to fix the challenging process, engineer a challenge. And that's what I always saying to our teams, we need to think out of the box. And thirdly, we need to have a good management. We want to finish our project on time before the deadline, of course. And also we need to make sure we manage our resources. We have proper vendors can provide our products. And also the TURI is one of the biggest resources in this project because they have wide network we can talk with. They have a similar project we can use as a reference. But as in the core of this project is the execution. So we want to do the project really fast and swiftly to perform what we need to do once we have idea. So those are the lessons we want to know. And I would like to share this project to you guys so you can use the similar concept and you can similar methods when you do your TUR projects. So I really appreciate this webinar held by the TURI. So I really want to share all this idea, how we develop these dual brushes and how we start a project from 0 to the 1. And eventually we reached our goal and we save plenty of money for our company. And then we protect our employee from operating more hazardous chemicals. So this project is so successfully, and I will continue the partnership with the TUR, Toxic Usage Reduction Institute. So these are the project we finished. If you have any question, don't hesitate to ask me.
Thank you, Shuai. What a wonderful presentation and really great description of what you did and why you did it. So really, thank you so much. I do have a number of questions that have come through the chat, so why don't I pose those to you now? And for those of you listening in, please go ahead and add any other questions you may have to the chat box now. We'll get to as many of them as we can in the remaining 10 minutes. So first question was about the amount that you reduced, and you did show us that. I have a, yeah, there we go. So quite a bit of chemical saved in just 50 days, right?
Yes, we did assessment of the 50 days because those 50 days I manually measure it because after that, the ultrasonic sensor will automatically pump the acid back to tank. So the sensor will maintain the dual brush tank in a specific level. So instead of changing it, because we want the acid level become steady.
Great. Has there been any impact on the quality of your product by recycling this?
Actually, no, because we reduce the acid and we pump back to the acid. So the wire mesh, the only impact is that once we reduce the acid back to the tank, we're using the same acid because those acids is residue from the wire mesh. So so those low concentration acid is the same we're using in acid clean tank, and also it actually increase the quality because when some wire mesh have not only residues of the liquid but also have residue of the grease and dirt, which is not cleaned by the rinsing tank. Those wire mesh will help the cleaning efficiency. So the wire mesh will physically sweep all those solid residue from the surface. So it helps with the cleaning of wire mesh, especially because this is the surface surface treatment process. We want the wire be clean as much as possible.
Terrific, thank you. Do you think that this process would be something that could be used to recycle and reduce the use of sulfuric acid in an anodizing system?
I'm pretty sure, because one of the biggest challenges in this project, and I mentioned why we don't use other method, is that the surface, the shape of the wire mesh is not a flat surface. It's like it's really hard to remove the liquid from the surface, and since the brush that we're using has a really high density, so it can reach all the corner of the wire mesh and totally remove all those acid from the surface. So this is really good of the brushes, especially for those irregular objects, compared to our other place or flat surface. So this is our benefit, and that's why the reason we decided to use the brushes.
Yeah, that's great. And I imagine, depending on the material that you're working with and the layout, the geometry of the materials itself, you may want to change the type of brush, the specifications of the brush.
Actually, so if you have a different shaped object you want to clean the surface residue, I would recommend instead of use this. Let me show you the drawing. So instead of using the solid shaft, you can use with different angles. You can rotate in different ways. Just you can design the brushes and how they rotate just based on what your products, what your object want to optimize. So I designed this whole tank because the wire mesh will continue to travel through from tank to tank, and this is like station. We let the wire mesh travel, but we stop the liquid from the middle. So if you want to duplicate this application on your business, I would recommend you can still have a tank to collect it, but the brushes and the shaft you can design on your way. There's plenty of other options you can choose.
Right. Great. So a question about the brushes themselves. Do you anticipate needing to rinse those brushes off periodically? And what are your thoughts on how you'll manage that?
Actually, we don't. We have used some brushes in this business long times ago, but we're barely now using for collecting assets. So basically, we have some similar, but just to remove the solid residues and some dirt from the surface. But we're not using even the cylinder brushes. We use just the flat brushes. So the cylinder brushes will continually rotate backwards and sweep all this liquid from the surface. So this is a really magic part for this project because it's pretty unique, especially for the wire mesh business. And it function properly. And as I mentioned on the diagram, we averagely recycled about 56 gallons of those low concentrated liquid in our tank. So think about this. We let all those low acid go past the process and direct into our downstream process. Those are assets we're going to deal with anyways. We don't collect in our dual brush tank. We have to deal with it in our wastewater treatment system. So instead of letting it move to the next process, we stop here and pump it and put them back to where it belongs.
Mm-hmm. Great, thank you. So a couple questions related to your customer base.
Sure.
Do you have any customers that for whom you would have to get approval to be able to make a change in your process like that?
So firstly, I started, you mean the approval of this project? So
yeah, so in some instances, customers demand that a process be exactly the way they've contracted with you to have it be. do you have any customers for whom you would have to renegotiate in order to get approval for a process that has been modified?
Actually, so when we do the improvement process, when we install those two dual brushless tank, there are the part of the process of whole galvanized line. If you look at the processing here, the final galvanized product will be dipped into the zinc kettle and will grow a thin zinc layer on the surface of the wire. So the impact of the process is that we overuse other chemicals, but the quality won't be changed. So we still have how we decide the certification of the customer from the customer is that if we grow the specific ink layer on the surface of the wire mesh, and those are the indicator we want to show our customer. And obviously, those processes will improve the product, optimize the cleaning efficiency. So what do we do is that we measure the zinc layer before and after, and we found that we still have enough zinc on the surface of the wire. So those are the criteria standards. So we passed. So once we pass those ASTM standards, our customer will accept our products. But by doing this project, I work with our plant managers because I need to prove with them, and also I contact with TURI, and TURI will help me, support me to guide how we implement and what is timeline and how we organize the whole project.
So a couple more questions, Shuai. Oh, and just a quick question: does Riverdale Mills intend to market this as a greener process, or are you just doing this for your own internal benefit? Is this is this something that you think Riverdale Mills might be marketing as a greener process?
You mean a greener process?
Yeah.
Maybe, but I'm not really sure about this part because for me, I'm not only one person who focused on the process improvement, how we deal with all this engineering technical problem challenge. So
you're not the right person to.
Yeah. So those are probably I'm not really familiar with.
And I think it certainly wasn't one of the motivations for engaging in this, so that's fine. The increase in energy costs, there was an increase in energy costs, is that right?
Yes, because we never used something in this place, so we added a pump. So I can show you in here. So we added 2 pumps on the production line, and we need to maintain, because our plant is running 24/7. Sometimes we run 24/5. We always have the wire mesh pass through all these production line. So we need to continue to keep those brushes running, and keep the pumping acid back to the acid clean tank. So those are the utility I estimate by using the calculator, because we're using like a 3/4 horsepower pump we're using, and also we have using the 4 gearbox to maintain the 4 shafts of the 4 brushes. So those are utility costs we estimated. And
you did capture that in your cost estimate, so that was great.
Yes, right.
We had a couple other questions, but we're at the hour, and I think what I'd like to do is just to really thank you again for a wonderful presentation.
No problem.
Certainly some folks have noted that on the chat as well. This has been recorded, so we will have the recorded version of this presentation on our website. If you have questions about the grants themselves, you can certainly reach out to Joy. We do have plans for other virtual demonstrations in the future, so stay tuned. Joy, any last words?
I just want to thank everyone for joining us, and thank Shuai for such a great project and presentation. It's been a pleasure working with you.
Yep. Yay. Okay. Thank you, everybody. Take care.